Može samo za zatvaranje vrata iza, molim vas. Hvala. Ja ovako imam, inače, dosta dubok glas, pa kad sam zadnji put pričao, toliko sam bio glasan da sam me u drugoj dvorani smetao sam predavaču, pa mi je došao mahat, daj malo tiše priče. Tako da malo ćemo pokušati s vratima izolirati, zvuk. Slijedi nam sljedeće predavanje sa vrlo zanimljivom temom. Onako, svi mi developeri, kad se nešto može automatizirati, ovi naše razvojne okruženja, kad dobijete nešto na next finish, to je super, pa onda ne morate vi programirati. Ali ovo je nešto korak dalje, gdje ćemo praktički pokazati jedan novi koncept koji će nam ispričati Marin Orlić. On će pričati na hrvatskom ili engleskom. Znači na engleskom će pričati. So we will see what's about our semi-automated software development. And remember, I have many presents to give, so please ask questions. I have cards, cups, T-shirts, so please. I don't want to take this back to home. So please, Marin.
Okay, did you see this presentation before because you knew everything that's in it? So, okay. So yes, thank you for filling up the room. So before I start, just a few minutes about me. So my name is Marin Orlić, and I'm interested in modeling, for instance, behavior modeling and how to model behavior of a software system. Also, cloud computing, and also the topic of today's talk, the automated software engineering, or the AC. Although I think the name is a bit wrong, I think everything should be automated, and AC should be called just software engineering and not automated software engineering. And instead, what we do now should be called manual software engineering, because it's not the way to go, actually. Okay, so I used to work at the university, as some of you may know, and roughly a year and a half ago I switched to Ericsson Nikola Tesla, and I work at the Research and Innovations unit there, and we have lots of interesting projects, and this is one of them. So almost a year ago we had a kickoff of this project, so this was in Greece in November, in Thessaloniki. And so we had roughly a year or so in the project, so I'd like to present what we were busy with during that year. Okay, so the full name of the project is Scaffolding Scalable Software Services, which is a really complicated name, but what this actually means is prototyping cloud web services. So this is my interpretation of the meaning of the project. So we want to have a way to prototype web services which are then deployed in the cloud. Some brief numbers. So it's a 3-year project. It's funded by EU FP7. We have 9 partners across 5 countries that include Greece, Croatia, Germany, Italy, and Scotland, UK for now. Okay, so the main idea of the project is that now, these days, when you do software development, you have this loop where you have your idea or your concept. You write requirements, then refine those requirements into specifications. So write it more detailed way. Then go into the design phase where you actually think about the architecture, how you're going to implement these things, perhaps create some sketches, some models, and then you do the prototyping. So in this phase, you actually implement code. And then, if everything is okay, you got yourself sort of a product. But if not, then you need to go back to requirements and redo some things. So this loop is something that we have in our daily work. Here at this prototyping phase, we typically use some existing artifacts which are available online, for instance, libraries or code or components or web services in this case. So most of the things that we reuse online are used many times. So it's not that you use a framework only once, you're going to use it for many projects. So this is where S-CASE comes in. So our idea is to go very quickly and in an automated fashion from requirements to the prototyping phase. So what we would like to do is to have an automated way of analyzing requirements and then putting together all those existing artifacts and create a ready-made prototype. So this figure here shows an overview of our entire process. So here on the left top we have the input, the requirements to the system, which are often specified as natural language text. So we have some English text that specifies that the system should be able to do something, or the user should be able to log in into the system. We often have some storyboards or UML interaction diagrams or just flowchart which are drawn on the board. So we have some means to describe the dynamic aspects of the system. We might have some analysis class diagrams, which is actually just a description of the domain of the application. So you have just the concepts and the relationships between concepts. And then you could have UML diagrams which are all of these things, but in a more formal way. And those diagrams could be a proper model. So you might have an XML file from a UML tool, or you might just have a screenshot from somebody else's documentation or a figure in the PDF file, or just a sketch on the board. So you could have a diagram that is drawn by hand. So those are our inputs for S-CASE. So the first phase is to actually identify all these requirements and try to extract all the things which are mentioned in these requirements. So like I said before, we focus on the web services. So we do not do everything because it would be almost impossible. So we just want to focus on how to create RESTful web services. So in order to parse the requirements, we need to extract all the resources and all the operations which are done on those resources. So once we have this, we can transform this information, this knowledge, into an ontology form. So this is a way of representing knowledge. And then we can work on this. So it's no longer a human readable format. It's not text or images. It's now in an ontology format which can be used by the computer, by the machine, to actually generate some code. But of course, it's not that easy because you can't just directly generate code from the requirements. So that's why we have this diagonal line. So first we need to see if we can find existing functionality that matches what you want to do. So for instance, if I have a requirement that my application is supposed to do some transactions online and do some payments, then I know that there might be some online services that I might use for the payment part. So then S-CASE will go into its own database, into its own repository, and try to find all the services that are suitable for this task. So it will search all the data it has and try to find a payment service. So now that we have all this information and we can map the services which fit into our task, then we can go and proceed with the code generation. So now from the middle of the diagonal part, I'm moving to the right side, to the right-hand side, where you have a typical model-driven engineering process, where we generate a SIM model. So that's a computationally independent model. So it's not related to any architecture or any design pattern. So from the ontology and from the knowledge of which services we want to map, we can create this model. Then the next phase is to extract a PIM model. So that's a platform-independent model, which has some architecture, but it's independent of the language or concrete frameworks. So that's the second step, and then we transform this into a more detailed model, which has this information about the platform. So it's a platform-specific model, and then we generate code. So once we have code, we can build it and deploy it on the cloud. So now you probably have the question, okay, so where do we get all this information about the web services? So that part is on the left-hand side at the bottom. So we have this green cloud, it's internet, so whoever wants to provide a web service can do that, of course. And we have tools that can actually map information about any web service to some domain knowledge. So information about transactional payments, and then store this information into S-CASE database, so that we know how to use this service. And of course, all this will be deployed in the cloud, so you could actually deploy your own service that you create with an S-CASE tool set and deploy it in the cloud and run it, and it will automatically be registered in S-CASE. Okay, so now I have the demo. So before I switch to the final slides, I will show you what we have. So. Do you hear me with this? Yes? Okay, so let's say we have something like this. So we have some textual requirements. And we say that the application must be able to check if it's connected to internet, and the user must be able to log into application using Facebook account. So this is in English text. It's natural language text. And I can use this one. I can use a parser tool that's an NLP component, so it knows about the natural language process, and it can extract the meaning of the sentence. And of course, natural language is a fairly difficult thing to analyze. So my machine is not really fast, and it will take some seconds to actually load the models that describe the English language and the requirements which can be written in English language. But once it loads, it will extract the requirements. So here you see the loading. And of course, this is just a prototype version of the tool. So now we have everything just running locally. There's no deployment in the cloud. There's no running as a service. So that's our next step. So once we're done with this, of course, this startup phase will not be that slow. Okay, so the actual parsing took just 3.5 seconds, but the load took a lot more time. So that will be, of course, fixed in the future phase. Okay, so what you get outside is not from the parser is not really interesting. It's a text file with some mappings, but we have tools that can help us visualize what we got from the requirements. So here you can see visualization, and I think I have a newer version. So this one may be a bit newer. Okay, so you can see that for instance, for some sentences we got for instance, for the first sentence we know that the actor is the application and it's supposed to check if it's connected to the internet. So the parser detected some properties, and for instance here we have the action that the application logs into an account. Of course, this is not perfect yet. It still needs to be polished. So depending on the way you write your requirements, it might work better or worse. So it's all the matter of the training data we have. So that's also one thing that I'll talk about later on. So okay, now what we've done is we analyzed the textual requirements that I got for an application. Okay, so let's say I also have an UML diagram. So for instance, it might be something like this. So this is pictures. It's a PNG file, and it's not really usable because you can't really do anything with it. You can just paste it in the document, and that's it. But I would like to have a model, UML model extracted from this. So this tool is the UML diagram recognizer, which can do this. So I can take a figure. Let's take this one, image size, and it takes some time to analyze the picture. But in the end, it will create. So from the input side, you can see it's a picture, and you get the analyzed form, which is actually optical recognition, and the tool can recognize all the forms in the model, and based on their shape, it will create an XML file, which is the model, the actual UML model that represents this image. Okay, so that was the part related to the parsing of the input. Okay, so the next step is actually magic because we didn't implement it yet. So now the next step for the project in the next year is to be able to put all these requirements together and create a sim model that will describe the system. So that task is fairly difficult, and we'll work on this in the next year. What we have now is the step that was on the right-hand side in that figure. So we can generate some code from the sim model. So for instance, you can write a sim in a format like this. So you have just a text file that specifies the resources. Remember that we're discussing REST web services, so we always have some resources. And so this part here will actually list all the resources, and then each resource will be defined in more detail, so with a name and a flag if it's algorithmic, and we'll possibly add some more information here. For each resource, you can also define properties and representation, so you can say that you want to use JSON or XML or similar, and you can also define CRUD activities, so if you want to read, update, delete some resources, and of course relations. So for instance, for an application that we build using S-CASE, we have resources like this. So it's a list of resources that actually describe a web service. So the application that we're building here will be used to map web services into our database. So it has all these resources. Okay, so what I can do next is then call the tool that will create code from this specification. So this one runs a bit faster because it's a simpler process than NLP. And it will create all the code in Java because we implemented just the code for the Java platform. And I get an output like this. So I don't need this. So I get all the resources here, and for instance, for each resource you get all the handlers, so all the code that's actually necessary to run the service. So then I could deploy the service, which I did already. So I have this code. Okay, it's a different name because it was tested. Okay, sorry. So it's running in VirtualBox, but here's the output. So when you connect to this web service, you get the standard API from a web service. It is running in a VirtualBox, so I can show you, but it's not. My terminal just disconnected, so I don't have the tunnel anymore. But anyway, I have the application running on the VirtualBox, and it automatically created the database, and all the code was compiled and deployed to the web container. So this works. This can be fully automated, and it works as it is right now. Okay, so now we have the big picture. So what are the tools that we have right now? So of course, this is not the way that you would want to use it, because it's not really user-friendly. You need to call all these command line applications. So we have built an IDE in Eclipse, or will build an IDE in Eclipse. So this is just a mock-up that shows what we could do. Our idea is to actually have a dashboard. So here at the bottom is a sample dashboard that will guide the user through all these steps. So it will help us to create the project and create textual requirements. So for instance, here we have an editor for the textual requirements. And you could also create use cases in a UML diagram or analysis classes. So whatever you want to define your application in a static way. And then you can also specify dynamic models. So you could, for instance, create storyboards. So there's also an editor for storyboards, which is more or less a workflow diagram. So it's nothing complicated, but we have the opportunity to include to specify steps where we want to include some web services. So for instance, here I could specify that I want to do some payment. Okay, so this is the part that actually specifies what our application wants to do, and now we would move on to generate all these models. So this will be integrated in the tool. On the left-hand side, you can see the view of our system. So we have all the artifacts that define the system. So all the requirements, all the models, everything. So for instance, here we would list the textual requirements as text, and we could also include models, so you could see all the data that defines our system. And then once you generate the SIM and PIM and PSM, you will also see those models here. So you have the static view, the dynamic view, so the activity diagrams, which can be done in UML as models or as images, and you also have storyboards. So once you create the models, you could go into the step where you actually map existing web services to the functionality that you need. So for instance, here I have a definition of web service that wants to create a word cloud out of some text. So for that, I need to have a service that can extract text from an URL, and can also, so that's the first step, and then I need something to create a word cloud image, so that could be the next service. So we could actually map two different web services into two places in a workflow. This would be done automatically. So S-CASE will try to find the matching service, and of course, if automation is not possible, then it will ask the developer, okay, so can you please choose which option you prefer more? So for instance, here we have three options. So for instance, for some services we couldn't find a proper match. So if we combine these three services together, this one will perhaps not work, and this one is marked as optional. So this solution is also acceptable. Okay, so once you create a composition of existing artifacts, then you move into creating the source code and deploying and everything else. So the part that you saw before. And of course, we can also add some developer nodes which might be useful in the future and which are also stored in the S-CASE repository. So that's it for the developer. We also have tools for the service providers. So if you have your own service that you wish to share with the S-CASE community, you can create like you have your deployed web service, and you need to annotate it so that S-CASE knows what are the operations that your service has. So I have some samples. So this is a tool that is actually working, and it has a few application domains defined. So of course we can define everything. So we have just the geographic domain, transport domain, communication domain, business, and leisure. So it's sort of at this time limited to these 5 domains, but this will of course expand. So for instance, if you put in your web service, so I don't know if internet works, so I'll try to click here and see what happens. It will try to classify the information that it gets from your web service, and it will try to map it to the domain knowledge that it has. I don't think it worked because nothing changed here. But yeah, perhaps it's due to the internet connection, but the tool is working. So when it parses a service, it will try to match all the inputs that the service has, so all the input methods, to the domain methods. So for instance, for the payment service, I have some conversion methods, so I can convert from one currency to another currency. So that is a typical method that belongs to this domain. So I can find this match with 100% accuracy. But for the case of the conversion rate, the accuracy is just 33%, and then I need to check if that's okay. So perhaps I will need to go through the list of services and see if this method was annotated correctly. This needs to be done for both inputs and outputs. So I need to check if all the inputs and outputs are matched correctly, and once it's done, then you have your service annotated, and S-CASE can actually use it, and developers can find it. Okay, so that was it with respect to the tools that we have. Okay, so now I'd like to ask you to, of course, see what S-CASE has to offer online. So we have a website, we have a blog page, so we have monthly updates on what's going on. So please check the website, join us on Twitter, join us on LinkedIn, Facebook, and there's also code on GitHub, so you can download all these tools in source code, and you can build it on your own. There's also one thing that I'd like to ask you, so I'll keep this slide open during the questions. I have a short survey, so if you're interested in participating in the project and would like to perhaps influence how these tools will be done, then you can contact me or fill in this survey and leave your information. So leave your email or just some comments. You don't have to participate in anything. You can just say that this is not your thing, and that's also fine. So, for instance, if you have any requirements that you might be willing to share, so for instance, English text, because we accept only English, so we have English text that defines the requirements. We could use this to train our tools and then get better accuracy, and that will also be useful for you because you could then use the tools in your own company. Okay, so that is it for me. We have a few minutes for questions, so please remember. Microphone, please. Yeah.
Hello. This is loud. A question regarding specifications. So you parse those specifications to create an ontology.
Yes.
How sensitive is your parser with regards to poorly formatted sentences?
Okay. Well, that's the difficulty with natural language. So you need to realize that natural language processing is really easy for us, but it's really difficult for the computers. The good thing for us is that requirements are usually not that complicated, because you typically have a sentence that's complete in itself, so it has some meaning. You don't need to read the whole paragraph. Because it's usually in a table, so it's not a text that you need to put together and connect all the sentences. And typically they are in a format which is like subject, verb, object. So that one is of course recognized, and we can also recognize more complex sentences. And for this task we had a data set of some, I think, 2,000 requirements which were gathered from various sources, and this was used to train the parser. So for all the typical sentences that we got there, the parser can handle this. But if you try to write something really complex, it will not work, of course. So one benefit here, actually, is that the tool will sort of guide you towards creating requirements in English which are understandable, because if you write some convoluted sentences which have lots of commas and parentheses, this is not good practice anyway, so you do not want to do this at all. So, did that answer your question?
Yeah. Thank you. And another one, last one.
Of course.
What kind of artifacts can the framework technology create apart from web services?
Okay, so the goal was to focus on the creation of web services, because we need to be finished in 3 years. So we can't do everything, of course. So what we work on with right now is just RESTful web services. So we have constraints that the service will be RESTful. It will be implemented in Java. It will run on, I don't know, Jetty or things like this. So JAX-RS and all these technologies. Database will be handled by Hibernate. So those are the constraints. But when we create all those models, so we have the SIM, which actually specifies your application without going into any architecture. So if you want, you can create your own extractors to transform the SIM into PIM, PSM, or whatever. So we intend to support creation of custom tool chains.
Now, you've mentioned that there's a matching of services based by a name in the text requirement. How is this matching actually done? Is there some simple text search algorithm that goes through the tags, or I would like to know more about that.
Okay, so that was the part that I said that's magic right now because it's not implemented. The idea is to have, so we do not search the text as is. So we always parse the text with NLP tools to create an ontology that has all this knowledge that's embedded in text. So once you have this, you know things like what are your actors. For instance, here you can see that that for some sentences I know that the actor is the user and the operation is login. So then I can search all the services that have this domain operation. So for instance, if I want to pay online, then this payment is a domain operation, so I can match this to an existing service. So we'll have some ontologies that will actually connect from the specification of your application towards the domain ontology and then to a service. So, that's the way.
Is there a way to manually change the web service when it's created? So, I don't know, like 95% of the requirements are parsed correctly, and then the other 5% are, not done well.
The goal is to provide traceability through all the transformations, so that you know that this requirement actually resulted in something that was done at the end. So we need to know what happened on the road from the requirements to the code. But to actually be able to do the full loop, and you can write your code, and that's parsed back into the system and then integrated, that's really too complicated. So our intention is to focus on the requirements. So you will need to change the requirements or add a new requirement if you want to change some functionality, if you want to use S-CASE to generate everything. And when you have code, you're of course free to change or adapt. We realize that everything will not be automated, so we can't generate everything. So the goal is to actually do the best effort to create a prototype that has all the blanks filled in, and then you need to add some functionality. So for instance, you might have a resource that's not actually taken from an existing web service, but needs to be implemented in an algorithm. So that's not, of course, for S-CASE to do, but S-CASE will do everything else around this part, and then you can plug in your algorithm and create something with the skeleton that S-CASE can generate.
Is there a format for the functionality that is like 100% accurate? Something like a DSL that are you thinking about doing something like that?
We have some DSLs internally, so we have models which are specified internally, but all this at the functionality level, everything is in an ontology. So we have a document that describes the ontology that can be used to describe the functionality, the intended functionality of the application. Is that your?
Okay, please. This is the last question because we run out of time, so please.
I would like to ask the question regarding reusability. If you always start from the requirements and you go all the way to the end to finish the application, you do the test and everything. Now, how would you do the same for very similar company? How would you handle variability and to use some already generated artifacts, and how would you handle commonality? Like two things: reusability, commonality, and variability of already generated artifacts.
Okay. That's a great question because I forgot to mention something. So, thank you. So here you can see the search that we also intend to implement. So this will be sort of Q&A service in S-CASE tools. So you'll be able to pose English language questions and search for artifacts that have certain properties. So the idea is that you work with S-CASE over a few projects. So you collect all this information. So you have all the artifacts, you have all the requirements, you have the code, you have the services and the specification of the compositions and on the mappings, and then you can search on the database. So you can, for instance, here you could ask, where did I implement login in all my projects? So you will get all the requirements that relate to the login method or operation, and you could also get all the artifacts which relate to this one. So you could get services and code and perhaps some pieces of code that you stored into the repository for future reference. So this is sort of way to help in a situation where S-CASE can't really automatically create everything. So if we have some variations, then you'll need to find some matching code or artifacts from a previous project. So our idea is to have a search, let's say, engine. So that's a query answering engine that you can ask to find some things in your projects. So it's not directly, I think, your question, but it's in that.
Okay, thank you, Marin. We have to go further.
Thank you.